Hi, welcome back to recitation. In lecture, you've been learning about applications of integration, and one of them is how to compute average values of a function. So I have a nice average value problem for you here. So Christine was out jogging one day, and she saw a bear, and so she broke into a sprint. So she starts speeding up, and her velocity t seconds after she started sprinting is given by v of t equals 1500 divided by the quantity 100 plus t minus 5 squared, the whole thing minus 7. And then it's in meters per second. So she starts at t equals 0. She's going 1,500 divided by 125. So that's 12 minus 7, so 5 meters per second. And she starts to speed up. And after 5 seconds, she's going 1,500 divided, well, this is 0, so that's 15. So she's going 8 meters per second at 5 seconds. And then she looks over her shoulder and she sees, oh, no, it wasn't a bear. It was just an unkempt math graduate student. So then she starts to slow down again. She slows back down, and 10 seconds later, she's back to her original velocity. So the question is, over the 10 seconds of this sprint, she sped up, she slowed down from 5 meters per second to 8 meters per second, and then back to 5. What was her average velocity over this time? So why don't you pause the video, take some time to work that out, come back, and we can work on it together. So hopefully you had some luck working on this problem. I have over on my left here a little picture of the graph of this function v of t. I described it to you earlier, but just you see, OK, so it starts at 5. After 5 seconds, it's at 8, and then it goes back down to 5 at 10 seconds. So this is roughly the picture, just so we have a feel for what we're working with. Now, what we want to compute is the average velocity over this time. So anytime you have to compute an average value of any function, what you want to do, you always do the same thing. So you want to compute the total contribution of that function over the interval in question. So you want to add it up. You want to integrate it over the interval in question. But then you want to divide by the length of the integral. So in particular, when you have a velocity function, what that means is you integrate the velocity. So that gives you the total distance traveled. And then you divide by the time interval. So you're just taking total distance divided by total time. So in this case, we can write down this average value. So I'm going to use just a made-up notation. I'm going to write AVG for average of v. So what is it? Well, OK, so the first thing I have to do is I want to not forget to divide by the length of the interval here. So in this case, the interval is from 0 to 10. So it has length 10 minus 0, which is 10. So I want 1 over 10 in front. And now what I want to multiply this by is I want to multiply it by the integral over this entire interval of my function v. So I just take the formula that I had over there for v, and I plop it down into my integral. So it's the integral from 0 to 10 of 1,500 divided by 100 plus t minus 5 quantity squared minus 7 dt. So this integral is the average value that we're looking for. OK, so now we have to go about evaluating it. Now, this looks kind of ugly, but actually it's not that bad. I mean, one thing you can notice, so the minus 7 part, that's going to be easy to take care of. And then in this more complicated part, well, there's a kind of obvious substitution here. You could set u equal t minus 5. That'll simplify it a little bit. And then what you'll see is that you'll have an integrand of the form something divided by 100 plus u squared. And so that's 10 squared plus u squared. So that should keep in the something as a constant. So that should put you in the mind of like a tangent substitution, or just even not by substitution. You could just remember that that's an arctangent type of thing that you're going to get out. So I'm not going to go through all the steps of doing that. But what you should get at the end, well, OK, so I've got this 1/10 out in front. So I have to not forget about that. So I get 1/10 times. So I've gone ahead and I've computed the antiderivative, and it's 150 times arctan of the quantity t minus 5 over 10. So here's that t minus 5. That's the same t minus 5 over there that's coming out, minus 7t. And you want to take that between t equals 0 and t equals 10. So this is, I've gone ahead, I've computed the antiderivative for us. There's my 1/10 because I'm doing an average value, and then it's a definite integral, and so I'm using fundamental theorem of calculus. There are my bounds. OK, so now we just have to plug in and evaluate. So this is equal to, so let's see. So we've got, when we put in t equals 10, well, the 1/10 and the 150 gives me a 15 arctan of 1/2 minus, well, it's 1/10 of 7 times 10 is just 7. That's from the first one. And from the second one, I get minus. So it's going to be 15 arctan of minus 1/2 when I put in t equals 0. And when I put in t equals 0, the 7t is just 0. OK, this is a little messy. We can simplify it a little bit, because remember, arctangent is an odd function. So arctan of minus x is minus arctangent of x. So minus 15 arctan minus 1/2 is the same as just 15 arctan 1/2. And so we can combine those. So we can rewrite that. Let's go all the way over here. We can rewrite this as 30 arctan 1/2 minus 7. So that's about as nice a form as you can make this take. If you wanted to plug it into a calculator, I think you'd see that this is approximately equal to 6.9. And I guess the units there are going to be meters per second. So her average velocity over this time is about 6.9 meters per second. Let's just quickly recap what we did. So we started all the way back here with this velocity function v, and we wanted to compute its average value over the interval 0 less than or equal to t less than or equal to 10. So we did what we always do in problems of that sort. So we came over here, and whenever you want to compute an average value, you take 1 divided by the length of the interval in question times, then just you integrate the function whose average value you want over the interval. OK? And so then we computed the, well, we didn't show any of the steps, but we computed the definite integral by taking the antiderivative and plugging in. All right, and it happened that the answer worked out to be about 6.9. So there you go. I'll stop there.